So again, good morning to all. So in the last lecture, what we have seen that the concept of array as well as some part of structure. Okay. So let me explain again the problem of array. Let's say it is an array. Okay. Let me put like this. Okay, it is an array, and the name of the array is A. Are you following this? Let's say A is an array, and the name of the array is A. And what is my purpose? What I will do, I will store the elements inside the array. Okay, and I will store 10, 20, 30. So what you are going to do, if you will look closely, if the first element of array is at position 0, so it is understood that the second one will be at the first position, and then the second position, and so on. It means, what is the meaning of this one is, the meaning of this one is elements are logically connected. Are you following this? Elements are logically connected. And because elements are logically connected, so accessing is very fast. But as we have seen that in the case of insertion and deletion, in order to maintain this series, or we can see the logical connectivity, we have to perform a lot of shifting. So what I am going to do, I am going to break this connectivity. How we can break this? Let me explain to you. Let's say, let me rub this one. Let's say my task is to store the elements. So what we have done, first of all, I have taken an array. The name of the array is data. And the second one is the name, I have taken a similar array. It means the size of this array and this array are equal. Are you following this? Size are equal. And the name of the second array is link. So let me explain to you what I want to convey to you. Give me some minutes. Like this. Okay. So the name of the array is data, and the second one is link. So what is the meaning of this one is? The meaning of this one is, the moment I will store the first element, I will also instruct you where the second element can be found. Okay. Let's say the location is 1, 2, 3, 4, 5, 6, 7, 8. Are you following this? I am saying that, I am going to repeat this. I am saying that if the first element it is stored at the position 10, so where second will be stored? So I am writing this one. So second will be stored at the position 2. Okay. So let's say that is 16. If I have stored the second element, I am saying that after second element, the third element can be found at the location 3. So let's say it is 45. So you might see that, sir, what is the benefit of taking this one? Are you following this? Because it is understood that if first element is stored at the first position, second element will be stored at second position. What are you are going to save this one? So let me explain what is the benefit of this. Let's say the third element is 45 and the fourth element can be found at which number 4? That is 54. That's it. Okay. And fifth element can be found at the fifth, let's say 96. Okay. So that is the current scenario. If someone says that, please pay attention. If someone says that, please delete element number 3. Okay. So what is the requirement? The requirement is, someone says that please save element number 3. So what I will do, in a case of normal array, I have to delete 45 and 54 will come here and 96 will come here. Are you following this? That is a case of normal array. But in this case, what I will do, if someone says that please delete element number 3, so what I will do, first of all, I will start at element number 1. Okay. What is element number 1? Element number 1, so let me put a start pointer and put 1. So it is indicating that element number 1 can be find at 1. It means 10. Okay. So I have to delete element number 3. So now I will think where is element number 2. So by accessing this field, I will get at the second position. I will get the second element. Okay. Now what I am going to do, if I will get the second element, where is the third element? So by accessing this one, I will get that is the third element. So what I will do, I will delete this. Okay. So in this case, what I am going to convey to you, first the third element can be found at the third position. Are you following this? But what I will do, now I will not shift this element. I will change this pointer and will put here 4. Please pay attention, it is not so easy. What is the meaning of this one is, the meaning of this one is, first of all, the first element was a 10, second, third and so on. And I have saved this one. So I am going to break the relation of continuity. How I will break? I am not saying that element number 4, it is stored at element number 4. In order to access element number 4, what we have to do? First of all, look at element number 1 and at the link part, link matlab address. At the link part, you will get where the element number 2 is stored. So element number 2 is stored at second position, and element number 3 is not stored at the third position. It is stored on the fourth position. So compiler control will come here. Okay. So by putting extra array, you are instructing to the compiler that continuity is doesn't need to be maintained. Okay. By putting extra array, you can instruct compiler where the next element will be stored. Okay. That is called linked list. If you're not getting anything, not an issue. Let me repeat the concept. In linked list, a node contains 2 parts. So that is like start pointer, like this. A node contains 2 parts. In first part, we are going to save the data. So the first part is, let's say they start with 1 and the data is 10. And in this second part, what I am going to do, I am going to instruct compiler where the next element will be stored. So next element is stored at the second position. So I will write second. Are you following this? Okay. Then what I will do, I will take next block like this. At the second, what is the data? Data is 16. Okay. And where is the third element? At the fourth position. So we will write 4. So we have to reach not third, fourth. 54. And where is the next element? 5. Like this. So in the case of array, what was the problem? The problem was I was not able to solve the problem of insertion as well as deletion. But in a case of linked list, I am going to break the continuity. It means I am not maintaining continuity at the address label. So what is the benefit of this one is, I am taking an extra space, and in this space I am going to put the information regarding the next block, where next block can be found. Okay. So let me again explain this. So if someone says that what is linked list, so you will say that linked list is a data structure that contains 2 parts. In first part, we are going to store addresses, and in the second part, we are going to store. In the first part, we are going to store data, and in the second part, we are going to store addresses. Okay. So let me again explain the concept of linked list. A linked list is a data structure which contains a start pointer. It means it will indicate from where, and it is like from where the list will be started. Okay, it means the first block can be found at the block number 4. It is not block number 0. In the case of array, every time we are going to save the first block, that was 0. But in the case of linked list, I am going to specify where the first block can be found. Okay, let's say the data is 96, and I am saying that, oh, the next block can be found at the block number 5. Okay, and the second block, that is block number 1, block number 1, block number 2, and that the address is 4 and that address is 5. Okay, so the second block like contains data 20, and the third block can be found at the third position like this. So let's say the data is 29 and that is block number 2. And in last, when data will be over, we will put null. Okay, so that is null. So if I will convert this in a case of array, what is going to be happen? I have to take two arrays. So the first array like this, the name of the first array will be data as in the last case, and the second one will be link. Okay, like this. So let me take the block number 1, 2, 3, 4, and 5. Are you following this? 5. And let me take a start pointer. So that is start pointer. So where is the first block? The first block is stored at the 4th position. So the value of start will be 4, and it will point to the this one. Okay. So the value is 96. So let me put 96. After 96, where is the second block? The address of second block is block number 5. It means the second block can be accessed at block number 5 and the data is 20. If you have accessed the second block, where is the third block? Third block is block number 3. So we have to write block number 3. Data is 29. And where is the fourth block? First block, second block, third block, and fourth block. The fourth block, where is the fourth block? Like first block, second block 29 at the position 2. And that is null. Are you following this? So that is the example of linked list, and that is the array representation of linked list. So what is the benefit of this one is? The benefit of this one is you are not going to maintain continuity. The moment you are going to store data, at the same time you are going to record the information about the next block. If the first block is block number 4, at the same time you are saying that the second block can be found at the 5th position, it means 20. So if someone says that please tell me the data of second block of socket node, I should say node. So what is the meaning of this one is, someone says that I have to access the second node, that is the first node, that is the second node. So in a case of array, I can directly write A1. A1 is the address of second block. Okay, if we start from 0, and it is A2 if we start from 1. But in a case of linked list, I can't say that is 31. In order to reach node number 2, first of all, I have to reach at the block number 4. Okay, so that means start position. So at block number 4, I will get the first node, that is 96. Then I have to reach to the block number 2, and in order to reach block number 2, where is the second block? Stored at number 5. It means the second block is 20. Are you following this? So insertion and deletion becomes easy. Let me write insertion and deletion becomes easy, because in order to insert, in order to delete, you just need to change the value of pointers. Okay, but accessing becomes very hard. You can't directly access any block. Are you following this? You can't directly access. In order to access any block, you have to start from start. Okay, at a start pointer, you will get the address of first block, and then in a link part or in an address part, you will get the address of second block, and so on. So every time you have to visit every block. the moment you are going to access any node. Okay, if someone says that you have to reach block number 3, so first reach block number 1, then in address part you will reach block number 2, and in address part you will reach block number 3. Okay, so that is the introduction of linked list, and we have seen that in a case of linked list, accessing becomes very difficult because there is no mathematical equation like array you can directly access the address. Okay, in order to access the node you have to start from start and till go one by one. Okay, so that is the concept of linked list. We will discuss this one in detail also, but I have given you the introduction. Okay, if you are not getting anything in this video, you have to watch again and again. Okay, and you also look other resources too, but like on YouTube, what we have seen that many of the programmer implement linked list with the help of structure only. Are you following this? With the help of structure only, but I will do in this by two methods. The first one is array and the second one is structure. So we have seen the introduction by array, and let me discuss the concept of linked list with the help of structure also. So let me discuss the concept of structure. So in the last lecture we have seen that structure is a collection of different type of data. So what we have done that, let me put the data part. So let's say the data type is int. So in this what I will do, I will store data. Okay, and in order to, let me explain first. Like this. So what is the meaning of this one is, if I will take a variable of type person, it will be like this. So what is the meaning of this one is, the moment I will write this, what compiler will do? Compiler will allocate a block in which I can store data, that is 20. And what is the meaning of this one is, please pay attention. It says that I can store the address, the name is next, name is not important. I can store the address of type struct person. So what is the meaning of this one is, it can store the address of type struct person. So it means if I will take second block like this, let's say that is P1, let me take one more, struct person P2. So if I have two structure, what I will do, first of all, that is the second block. The name of this one is P1. The name of this one is P2. So what I can do, I can put the address of P2 into this block. So it will indicate this one. Let me explain to you. Let's say the address of P2 is 1000. Address of P1 is 100. So what I will do, I will put 1000 here. So what is the meaning of this one is, the meaning of this one is, first block is 20, and that because it is structured, so it contains different elements, and in second element I am going to store data where the next block can be found. So by putting address of this block into this field, I am going to connect these two blocks. Okay, so that is the concept of linked list by structure. Are you following this? Let me explain again. Let me take one more structure, struct person P3. So we have three block. Let me explain here. We have three block, that is P1, that is P2, let me write here P2, and that is P3. So I am saying that in P1 I have two parts, data and next. So let's say the address of P1 is 100, that one is 200, that is 250, let's say. Okay, so I am saying that please put data, let's say data is 100, and I will store the address of second node into here, and this block have a ability that it can store address. So what I will write? I will write p1 dot next equals address of p2. So what is the benefit of this one is, by putting address in this block of this block, I can connect these two blocks. Okay, it means the first data is 20 and second data can be found at address 200. Okay, let's say it is 60, and the third block can be found at 250. So we are going to connect this one. Okay, so in a case of array, what we have done there, we have taken two parallel arrays, and first array we have stored data, and second array we have stored the node number. In a similar fashion, what we are going to do, we are taking two fields in a structure. In the first field, I will store data. In a second field, I will store the address of next block. Okay. So in the incoming videos, we will see the programming part of this one. Okay. So I have given you the introduction of linked list by array as well as by structure. Are you following this? Okay. So in the next videos, we will see the practical implementation of linked list by array as well as by structure. Okay. Thank you for watching this video.